So I've had several questions recently about NX assembly mass properties management, particularly in the context of interpart modeling. And there are a number of ways that we can do interpart modeling, but in particular, I've had a lot of questions about how to avoid double counting masses when we're using wave interpart links, right? So wave interpart geometry links, of course, are a capability of NX for creating an associative linked copy of a body or a curve or a face or a number of other things, sketches in another part file, right? So we can do that associatively, change the original, the other one will update, and so forth. There are a number of ways to do this, some of which, all of which create a duplicate body. There's some interesting ways to do this where we will automate the mass properties calculations a little more than others, but we'll look at those here. I've got several examples here, as you can see, and I'm going to walk through these here, and we can see some different techniques and see what makes sense. And these different techniques here are going to make sense in different places. A little explanation or talking about it here first. Where it makes sense, using a promotion instead of a wavelink is going to do some things to help. Okay, a promote feature is used specifically for cases where a body from a component will be modified in a parent assembly. Right, it's always going to be linking upward one level. That's how they work. And the plan there will be to modify or combine that body at the assembly level. This might be used for things like weldments, for instance. It might be used for things like cross-drilling, match drilling at an assembly level, or even used for things like castings, for instance, where we may have an original part. We link it upward in a structure and then do some subsequent material removal, for instance, squaring off faces or drilling holes or things like that, kind of one level higher. So anyway, promotion is always one step up, and it's always intended to again modify the body at the assembly level. And in these cases, we know that specific use case, right? We know how that's going to work, and so NX will automate the underlying mass properties offsets there, while using the same underlying technology for linking as wavelinks. Okay, same mechanism underneath. But again, because it only works one way, we know what that one is, we know how it works, and we can automatically, from the mass properties roll-up perspective, it's the easy case, right? Because the user's intentions are clear. And again, if this is the specific use case for a customer, then Promote will, in fact, automate the mass properties effects. And we can see that. In fact, let's do that. Let's go look over here at NX for a minute. It's the green one here in the middle, right? But in this particular subassembly here, and I've got a couple extra layers of assembly in this here, just so that we can see the effects there. But if we look at this particular one, we'll open the subassembly here. There's this one component in here that's the block. If we open that one, we can see that component is just the block. At the assembly level, we've got a little bit of extra geometry here, right? Here I've got promote body feature. Again, this is going to copy the body upward into the parent assembly here, into this assembly from the component. The cylinders here at this assembly level, and then we might combine those, for instance, in a subsequent operation. But the point is here that in this particular subassembly, if we look back at the subassembly, the component mass here is 1/4 kilogram, 0.25 kilograms. And you'll notice that the subassembly here, although it contains a copy, it has the component and it has a copy of that body, at the subassembly level, the total mass here is correct. This is the 0.2585. We can look at that in the part navigator here for this part, actually, and this will maybe make a little more sense as well. If we look at this in this mode, we can see here that in the model reference set, we have a, let's see, actually the promote body is up here, and let me turn on the mass panels. The promote body here, you'll notice the mass of that is set to 0, right, automatically. as we bring that in. The cylinder here is this 0.085, and that's the little incremental bit that we see back there in the assembly navigator. Okay, so we're automatically zeroing out the mass of that promote body in this context when we're using specifically the promote body feature to do the linking. Okay, so with that, again, the component is here, the mass of the component is still here, right? But as we look at the assembly and what's going on in the subassembly there, we're doing the correct zeroing out really the mass of the copy here, offsetting that so that we have the correct subassembly mass. Okay, so again, this is the automated case. Promotion's easy, right? I'm going to go ahead and close these. So we're back to the top level assembly. And as we look at this one here again, up now a couple more assembly levels up even, right? We're in the context of this guy here. But we see that this one, again, the component has the 0.25 mass. The promoted assembly here also has the 0.25 plus the 8.5 for the cylinder, right? So this is kind of the target. This is what we want it to look like, right? Now, if for one reason or another we've used a wavelink instead of promotion, the challenge with wavelinks is that they can be used to link things bottom up like this, or they can be used to link things top down, right? Or laterally, to link tool bodies for subtraction, or for uniting things, or for intersection, or for construction, or reference. And we can't just infer exactly what the user is trying to do with wavelinks, because there's, again, a lot of ways to use them, right? There are, in fact, a number of customer usage scenarios for wavelinks where an automatic offset or subtraction of the original body properties is undesirable, highly undesirable, right? So when customers use wavelinks, we can't read their minds and auto-determine which of these usages they're attempting. And so we need some manual intervention from the customer to help handle the mass properties implications the way that makes the most sense in a specific design, okay? And so that's where here, because of the variety of ways that mass wavelengths can be used, right, we can't infer that treatment, and so we'll need to make some adjustments. And all those other examples in the model are these 5, right? So we'll walk through these and look at how these work and what the effects will be inside NX, okay? So let's look at these. Let's look at these here. Let's go right there. There we go. So looking at each of these first. So if the source part is not needed in the bill of materials, right, then one option is to remove the source part. So we can do this kind of a thing here, where this is our delete source one. So on this one here, again, you see that the component mass 0.25. In all of these with the wave name in them, if we open this in window and take a look, we have the component in here. In the part navigator, we have a linked body now instead of a promoted body. And the linked body is going to have mass, right? It does have mass here at the component level. And so this is where we get that duplication, right? We've got 0.25 from the original body, plus we've got 0.25 here from the linked body, right? And then, of course, the cylinder on top of that, right? That's the 0.085. And so in that context, this looks like we've doubled the mass, right? From just having the block plus the cylinder, we've kind of got the block twice here, right? And the cylinder. Now, again, if we don't need the component anymore, right? We do have an associative body here, linked body here. We can just remove that component, right? Delete that component. I use the delete key to do that. You can MB3 and delete as well. But as we do that, of course, the one drawback to this is that wavelinks will break here, right? That linked body here, its source, of course, is in the component that's no longer in the assembly, and so we'll see that this wavelink is broken, right? It has the broken link on it here now, and we can see that that's true. Now, this is not impossible to reparent, right? This is pretty easy to reparent. In fact, if we add that component back in, we can come in and reselect the body, and it will go find that just fine, right? But anyway, if this is a possibility, right? If this is okay, when we delete that, then we're left with just the linked body and the cylinder in the context of this part. And that gives us the right number, so to speak, that we're after here, right? So if we come back to this level here and look at that delete source, it no longer has that component 1 underneath it now. This has got a clean bill of materials in that respect. There's nothing underneath it. And we've got the 0.2585 we're after, okay? So that's one option there, okay? Another one, so again, wavelengths will break here, but we will have the ability to reparent those if we want to. Second one here, suppression is another thing that is a possibility, okay? And advantage here is that it's not going to break the wavelength as a result of this. The part will still be in the structure, but it'll be suppressed, right? We'll see what that looks like here in just a second. There are some companies that frown on having suppressed components in the structure. That's a choice that certain companies will make. So your mileage may vary there, right? But at any rate, with the source part suppressed, this will look a lot like the previous one, right? With it deleted, only the mass of the wavelength copy will remain in this case. So here, let's do that to one of these. So this is the wave suppress one. So we're going to suppress the source, right? And as we do that, we can come to that component, for instance, here and say, go to suppression and say we want to always suppress this. And what this will do, again, before we do it, again, we've got the duplicated kind of 0.5 mass in here right now. What this will do is show a different icon for this component that's suppressed. The mass goes away in this case, and we'll see that simplify, right? So as we suppress this then, right, again, we'll see that this one is suppressed. It's excluded because it's suppressed, and the mass is the 0.2585 that we're after, okay? So that's kind of a second technique there, okay? Now, third one is this guy. And this one's a little interesting. We could hide the source part mass out there by making it a non-geometric component, okay? Now, as this describes over here, this works really well, but you need to turn off a customer default that talks about non-geometric components participating in the roll-up, right? There are a couple different ways that customers like to use non-geometric components. This is one, if we're doing this, then we're going to not be able to use non-geometric components for things like fluids, for instance, where we're adding some mass to the assembly intentionally, but not modeling those components. So if that's acceptable, right, then again, we can go into customer defaults, go into gateway materials mass, and miscellaneous tab, and this non-geometric components participate in rollup needs to be unchecked or turned off, right? And if that's true, then we can certainly do this. So this non-geometric one is this guy right here. Very similarly, we can go to that component there and come to the properties for this guy and check this guy to say that this component is non-geometric. Okay. Now again, it's going to show a different icon for this guy. We'll see the mass go away here. The 0.5 is going to go to a 0.25 here, and it's going to look a little different, right? So this suppressed is the blue, the non-geometric is the pink here. Similarly excluded, right? And we've got the 0.2585 now that again is removing the duplication. Okay, so that's the third one. That was another possibility, right, for how to do that. Another one here that's a little tricky is if the mass of the source part is never needed, right, then we can use the mass reference set, override the mass reference set to empty. That'll make the mass of the part 0, and that will work. Now the trick with this one here, this preserves the assembly structure, which is nice. It doesn't have suppressed components, which is nice, but if we're overriding that mass reference set at the component level, which is where we'll need to do it, it's going to change the mass of all instances of this component to 0 all through the assembly, right? And if that's okay, then this works really, really well. If that's not desirable, then you're not going to want to do this particular one, okay? So let's take a look at this one. This one, this is the ref set to empty up here, which is this guy right here, okay? What we'll see with this one is that this one's 0.5. We got a 0.25 here. We still have this guy down here that's also 0.25, right? And what the caveat was describing there is if we take this one and the component, and at the component level, we change the reference set, mass reference set, zero out this mass. The trick is that everywhere in the assembly we have that component, it's going to similarly zero out the mass. Okay. And so when we do this one, we're going to see this one go to 0, but we're also going to see this one go to 0, and we're also going to even see this promotion one up here go to 0, right? So the promotion's going to not look right at that point. So you got to be a little careful with this one. If you're using promotions, this can throw things off if you're doing it with the same component. But let's go do this one. We'll set this to empty. As we go and open this one in window, we're looking at the component here specifically. Again, this one, if we look at the configuration context here for this part, is using the model reference set right now, which of course is bringing in this body, which has the 0.25 kilograms mass. We can come into the options for this part and override this, which is, again, not recommended, right, in most cases. But come in and say we want to use the empty reference set here for mass instead. And this empty reference set, as you would think, is empty, right? Does not contain that body. So if we do this, then we'll see that we've explicitly overridden this with the empty reference set. And of course, with nothing in it, this drives the properties to 0, right? So our from design properties here are 0 in this case. Now, with that in that state, again, as we come back and look here at the assembly, we'll see this mass reference set to empty. Again, that component now is asserted to 0, right? Which gives us the right answer in this context. And if this is the only instance of component 1, this is certainly a viable way to do it, right? This will work. In this particular case, of course, we've got component 1 all over the place. And up here, this one has also gone to 0, right? So if we update the properties here for the entire assembly, we can see that this one now is low, right? This should be 0.2585, but it's missing its mass from the original one with the promote. Similarly, down below here, this parent asserted one, we hadn't touched this one yet. It's ended up kind of in the right answer, but because we did this one, right? But again, everywhere we have that component 1, its mass is now going to 0. Okay, so again, if that's okay, then this is a viable technique. If not, it may not be what you want to do. Okay, so I'm gonna undo that one so that we can do these others first. So we'll turn off that override. This will go back to 0.25 there, right? And then we can see that the others here have also gone back. This guy's back there. Yep, and this one below has gone back as well. Okay, last one. So if we come and look at the asserted parent, right? This one here is the most manual method, and it's going to require manual updating as well, right? But this really comes down to directly asserting the mass of the parent assembly after we've manually subtracted the mass of the source part here, right? And this is really a last resort kind of brute force method, right? We're just overriding the numbers entirely in this case to get what we want. So for instance, in this parent asserted right here, we could open this little subassembly first so we can look at specifically what's going on here. We've got the component here. Again, we have the linked body and the cylinder, right? So all three of those are there. And in fact, if we come and measure here, for instance, and say, grab an object set and we grab, say, all of those solid bodies right there. This will come back and tell us we've got 3 bodies, right? Which again is the component, the linked body, plus the cylinder. And the total mass there is this 5085 that we've seen a few times, right? Now, if we don't want to include the mass of the component there, we can do this measure again, for instance, and this time we'll come and hide that component first, right? So we can't see the component. And then as we go to select these, we get just 2 objects this time. We've got the linked body and the cylinder out there, right? And now we've got that mass, that 0.2585, that is the right one we're after. Now, here's a little trick. When we did the new measure command, this table here now is a thing that we can copy from. So I can actually come and copy that value. And when I do this copy, it's going to copy actually not just the 2585. These are the 4 decimal places we've chosen to show everywhere. There's a UI preference to show 4 decimal places here, but it's actually going to copy the full resolution, full detailed answer here. And we'll see that here in just a second. So there's actually more decimal places out here that we're not showing right now, but those are in the copy buffer here as we've done that. So for instance, I can come to this component now, and if I want to assert now a mass, I can come and paste that value. And again, it's going to be the longer version of that. That is, let me edit that. There we go. And then we'll paste. There's the longer version, right, that's stored. And but at any rate, we've got that in there. We can choose now to choose our asserted mass here for this subassembly. And this is going to just fundamentally override the value at the assembly level here, right, for this component. So we can do that if we want to. So this is this parent asserted method. So as we come back again to our top level assembly here, this now will have, you'll see that parent asserted. We have the little finger icon that says that we've asserted a property here that's got us to the point 2585. Okay. All right. So that's all 5 of those, right? This one we reverted, right, because it was going to step on a bunch of others. But you can see here that, again, promotion is going to get us there the most automatically. Non-geometric works if we want to, if that's an option. If you're not using non-geometric for something else, that will work. Suppress is very clean, right? If you're okay with suppressed components, this is a very simple way to suppress, exclude a particular component from the mass rollup as well, right? Deleting the source, also very, very clean. If you don't need it in the bill of materials, you don't need it in the assembly navigator here, that will also obviously remove it. One downside is the wavelength breaks, but you can, again, reparent that if you need to, okay? Ref set to empty works. It's going to work everywhere, right? It's the thing to remember. And then the parent asserted, right, is the brute force method, right, where we're coming in and just giving it an explicit number. This one's not going to update automatically. We'll need to go back and retouch this here if it comes to that. Okay, so those are some methods, right, and I hope you find that useful. Again, a variety of ways that we can approach this problem, and if at all possible, going to promotion is going to be the best way there, right? For this kind of workflow, right? The one level up kind of workflow. If you're using Wave a different way and you need to treat the mass in a different way, remove a duplication. Again, here's some techniques that will be available, and hopefully one of those will get you where you need to be. And if you have any questions or comments or suggestions about this, feel free to give me a call or leave a comment below. And again, hope you find that useful.